Hey there. Today we're diving into the fascinating world of four-dimensional space. Imagine living not just in the three dimensions we know, length, width, and height, but adding another dimension into the mix. This fourth dimension isn't something we can see or touch, but it's a concept that can help us understand the universe in a whole new light. Get ready to have your mind blown as we explore the mysteries of the fourth dimension. Ever wondered what lies beyond the three dimensions we perceive daily? Let's take a moment to grasp these dimensions. First, we have length, stretching out in lines. This is followed by width, expanding into planes. Then comes height, adding depth to our world. Together, they form the three-dimensional reality we live in. But here's a thought to stir your mind. What if this isn't the end? What if there's more to reality than what meets our eyes? But imagine, what if there is another dimension we can't perceive? To grasp the concept of a fourth dimension, we must first comprehend what dimensions are. In the simplest terms, dimensions are the different facets of what we perceive as reality. We exist in a three-dimensional world, but let's start from the beginning, from the first dimension. Imagine a straight line. This line exists in one dimension. It has length, but no width or height. It's like a race where there's only forward and backward, no left or right, up or down. Now let's add a second dimension. If we take our one-dimensional line and draw another line perpendicular to it, we create a plane, a flat surface. This is the second dimension, where we have both length and width. Picture a piece of paper or a chessboard. There's forward, backward, left and right, but still no up or down. Next we add another dimension, the third dimension. This is the world as we know it, where length, width and height exist. If we take our two-dimensional plane and extend it upwards, we get a cube. It's like living in a building where you can go forward, backward, left, right, up and down. So we have our three dimensions, length, width and height. But what if I told you there's more? Just as we moved from a line to a plane and from a plane to a cube, there's a way to move from our three-dimensional world to something more. This is where the concept of the fourth dimension comes in. To explore this further, we need to think beyond the physical dimensions we're used to. This isn't easy, as our brains are wired to understand the world in three dimensions. But don't worry, we're all in this together. Now that we understand dimensions, let's delve into the enigma of the fourth dimension. The fourth dimension, often referred to as the time dimension, is a concept that has intrigued scientists and thinkers alike. The term dimension is used to describe the different aspects of our reality. But what does it mean when we say fourth dimension? In our daily lives, we interact with three spatial dimensions, length, width, and height. These are the parameters that define our physical world. We can move forward and backward, left and right, up and down. But the fourth dimension introduces a whole new level of complexity. So how does the fourth dimension differ from the three we're familiar with? Well, the fourth dimension is not spatial like the others. Instead, it's temporal. It relates to time. While we can move freely in the three spatial dimensions, our movement in the fourth dimension, time, is a bit more constrained. We can only move forward at a rate of 1 second per second. At least that's how we perceive it. Now let's bring in a bit of Einstein. His theory of relativity shook the scientific world by suggesting that space and time are not separate entities but rather intertwined in a four-dimensional space-time continuum. This means in a way that time is a dimension just like the three spatial ones. Einstein's theory also suggests that gravity is not a force as Newton proposed, but a curvature in the space-time fabric caused by massive objects. This is where the fourth dimension comes into play. The gravity of a massive object like the Earth distorts the space and time around it, creating a curve in the four-dimensional space-time. So if you're imagining the fourth dimension as another direction in space, you're not entirely wrong, but it's not entirely right either. It's a direction in space-time. It's like adding a new layer of depth to our understanding of the universe. Intriguing, isn't it? But how can we visualize something we can't perceive? Stay tuned as we dive deeper into this fascinating concept in the next scene. Visualizing a four-dimensional space is no easy task, but mathematics and physics give us tools to do so. You see, our minds are three-dimensional and we live in a three-dimensional world. We can grasp the concept of 1, 2, and 3 dimensions quite easily. But when we get to the fourth dimension, things start to get a little tricky. The fourth dimension isn't something we can see or touch. It's not something we can experience in the same way we experience the length, width, and height of an object. But don't worry, we have a handy tool to help us visualize it. Meet the tesseract or the hypercube. Now imagine a point, that's 0 dimensions. If you stretch it, you get a line, which is one-dimensional. Stretch the line at a right angle, and you get a square, which is two-dimensional. Stretch the square at a right angle, and you get a cube, which is three-dimensional. So what happens when you stretch a cube at a right angle? You'd get a tesseract, a four-dimensional figure. A tesseract is to the fourth dimension what a cube is to the third. It's a geometric representation that helps us conceptualize something we can't physically experience. In a tesseract, each corner is connected to four edges, which is something impossible in 3 dimensions. It's like a cube, but every point is also connected to another point in a different additional dimension. But remember, a tesseract is just a shadow or projection. It's a way for us to visualize the fourth dimension in our 3-dimensional world. The same way a drawing of a cube on a piece of paper is a way to represent a 3-dimensional object in 2 dimensions. So, are we living in a 4-dimensional world without even knowing it? Well, according to some theories, yes. Just as a cube is a shadow of a tesseract, we are but shadows in this 4-dimensional universe. The concept of a 4-dimensional space isn't just for theoretical discussions. It has profound implications in various fields. The fourth dimension is a pivotal concept in physics, particularly in theories such as string theory. String theory, a theoretical framework where the point-like particles of particle physics are replaced by one-dimensional strings, relies heavily on the concept of a fourth dimension. This theory suggests that there are actually 10 dimensions, not just the 3 spatial dimensions and the fourth dimension of time that we are familiar with. The existence of these extra dimensions could potentially explain some of the mysteries of the universe, such as the nature of dark matter and dark energy. In the realm of special relativity, the fourth dimension is essential. Here, the 3 dimensions of space and the 1 dimension of time are interwoven into a 4-dimensional space-time continuum. This continuum helps us understand phenomena like the bending of light around a massive object, also known as gravitational lensing, and the dilation of time in the presence of a massive object, often referred to as time dilation. But the importance of the fourth dimension isn't limited to the world of theoretical physics. It also plays a significant role in computer graphics and data visualization. In computer graphics, the fourth dimension is often used to represent changes over time, like the transformation of a character's position and shape in a video game or an animated film. In data visualization, the fourth dimension can be used to display multiple datasets on a single graph, or to represent changes in a dataset over time. This can be invaluable in fields like economics, where it can help analysts track changes in economic indicators over time, or in meteorology, where it can help meteorologists predict weather patterns. So, as you can see, the fourth dimension is much more than a theoretical concept. It's a practical tool that helps us understand the world around us and the universe beyond. The fourth dimension, though elusive, is a cornerstone of our understanding of the universe. So, we've traversed through the concept of 4-dimensional space, but what are the key takeaways? We started with understanding dimensions, the concept of length, width, and height, and how they give us a 3-dimensional perspective of our universe. We then took a leap of faith, venturing into the uncharted territory of the fourth dimension. It's not a physical space that we can see or touch, but a theoretical construct that helps us understand the complexities of our universe in a different light. We explored how to visualize this fourth dimension, a seemingly impossible task given our 3-dimensional perception. We talked about tesseracts, shadows, and projections, and how they help us get a glimpse of this elusive dimension. Remember, it's not about seeing the fourth dimension, but understanding its existence and implications. And oh, the implications, we discussed the importance of the fourth dimension in various fields. In physics, it's a cornerstone of Einstein's theory of relativity. In computer graphics, it's used to create realistic animations. Even in philosophy, it's sparked debates about the nature of reality and our perception of time. The fourth dimension may seem abstract and beyond grasp, but it's a testament to the boundless territories our minds can explore. Until next time, keep questioning, keep exploring.